This will be our last video for lesson 1 on matrices. We are going to do an example of a 3 by 3 system of equations. So notice that we still have x and y, but this time we have also got a column for z. So this is going to be more work. It's not necessarily harder work, it's just more of it, because we have extra numbers to get rid of. The nice thing is that we can combine our tasks to essentially minimize the number of computations. So I'm going to start off by labeling our equations E1, E2, and E3 for the first, second, and third. Since we have coefficients of 1 and -1 in this first equation, this is going to make it significantly easier to cancel out some of the other variables. And we could do that in many, many ways. So you might go through this example and do it differently, but we'll still both end up in the same final location. But the first thing that jumps out to me is I've got this negative z and then a positive z here. So I can immediately just do equation 1 plus equation 2 to cancel out this z. I still need to actually do the work, but I'm illustrating what's going to happen. And then I also notice that I have a y here and then a negative 2y in equation 3. So if I add 2 times equation 1 plus equation 3, I will end up canceling this middle term as well. However, for reasons that will become much more clear after we start using matrices, that is not the most efficient method. If I decide to use my first equation to get rid of z in equation 2, I should use my first equation to get rid of z in equation 3. So I would need to have 5 copies of equation 1 minus equation 3, because that would change this into a positive 5, and then we'd have a negative from up here, to cancel out this term. That's going to take a little bit of writing. So I'm going to pull out some color codedness. So we have E1 plus E2. So really straightforward. That's x plus y minus z is equal to 5. And then 2x minus 3y plus z. I should erase these so I can make sure I'm copying things correctly. Equals negative 8. And then I add them all together. So x plus 2x is 3x. Y minus 3y is going to be negative 2y. Minus z plus z cancels out. And then 5 minus 8 is going to be negative 3. We also have our second one. So it's 5e1 minus E3. So I need to multiply everything by 5. So we have 5x plus 5y minus 5z, and then 5 times 5 is 25. And then I have a couple options. I could either multiply equation 3 by a negative sign and add, or I can make sure to subtract each term. I prefer adding. So what I'm going to do is change all of the signs. So negative 4x plus 2y plus 5z equals negative 3. And now all I have to do is add. So 5x minus 4x is going to be x. 5y plus 2y is going to be 7y. And then negative 5z, positive 5z cancel out. And lastly, 25 minus 3 is going to be 22. Now we can write version 2.0 of our system. Actually, I'm not going to do the 0.0. It's just version 2. And we have our first equation, which has not been changed. However, we have changed our second equation. So I'm going to call this equation 2.2. And then our third equation, I'm going to call equation 2.3. Excuse me, 3.2. So to copy these down real quick, we have x plus y minus z is equal to 5. Then we have 3x minus 2y is equal to negative 3. And lastly, we have x plus 7x is equal to 22. Notice that I have an equation where the coefficient of x is 1. So that means I can use equation 3.2 to cancel out the 3x from equation 2.2 and the x from equation 1. So our new equation will just be equation 1 minus equation 3.2, because that will cancel out the x's. And then equation 2.2 minus 3 times equation 3.2, because I need to subtract 3 x's from 3x to make it 0. So I'm going to, same as before, get that written up. So I have E1 minus E3.2. And then we'll have E2.2 minus 3 E3.2. Right, so the first one, I'm just going to copy down x plus y minus z equals 5. And then I'm going to multiply everything from equation 3.2 by a negative. So we'll have negative x minus 7y, leave space for the z term that's not there, and then minus 22. X minus x cancels out. y minus 7y is going to be negative 6y. And then we have negative z. It doesn't change because there's nothing there to change it. And then 5 minus 22 is going to be negative 17, because 22 minus 2 or plus 2 and then plus 3. Yep, I'm pretty sure that's right. So this will be equation 1.2 because it's the second version of our first equation. Then over here, the top row is going to be equation 2.2. So that's 3x minus 2y equals negative 3. And then I need to multiply everything in equation 3.2 by negative 3. That first term is going to be negative 3x. 7 times negative 3 is negative 21. And then 22 times negative 3 would be negative 66. Now we add. 3 and negative 3 cancel out. Negative 2y and negative 21y, I forgot to write the variable, gives us negative 23y. And then negative 3 minus 66 is going to be negative 69. Now we can go a step further. Because we only have one variable, we can divide both sides by negative 23. Negative 23y divided by negative 23 is just y. Negative 69 divided by negative 23 is positive 3. So since this evenly divides, we can do it. If it didn't evenly divide, we would want to keep it as is, but that simplifies our equation 3. Hold on. I think this is actually 2. Okay. So this is actually equation 2.3. So now we have the third version of our system. So we have equation 1.2, equation 2.3, and equation 3.2. So 1.2 is negative 6y, and I'm forgetting something. I need to leave some space for my x term. So I have negative 6y minus z is equal to negative 17. Equation 2.3 is just y equals 3. And finally, equation 3.2 is x plus 7y. Okay, this looks very much like a y or an x. It should have looked like a y. I apologize for that. So it's x plus 7y is equal to 22. Notice that we have two equations that don't have x, two equations that don't have z, and now we have one equation that's just y equals. So we can use this equation to cancel out the y's from equation 1 and 2. Let me pick this color. I don't think I've used it yet. Have I? No, okay. So equation 1.2 plus 6 times equation 2.3 will cancel out the minus 6y. So we have negative 6y minus z equals negative 17. And then I'm multiplying everything by 6. So 6y, nothing in the z place, equals 18. So our y's cancel out. Negative z is equal to positive 1. If we multiply both sides by a negative, we get z is equal to negative 1. And this would be our equation 1.3. So equation 1.3, it is the third form of our equation 1. Then over here, equation 3.2. And this is a positive 7y, so I have to subtract 7 copies of equation 2.3. So we have x plus 7y equals 3. And then I need to multiply it by negative 7. So I have negative 7y and then negative 7 times 3 is negative 21. And I think I made a small mistake. So I switched these two by mistake. In equation 3.2, our third number is actually 22. I knew something felt wrong. It took me a moment to identify it. And now we add, so we just get x, 7y, and minus 7y cancel out. 22 minus 21 is just positive 1. And so this would be equation 3.3, since this is the third form of our third equation. So version 4 of our system. We have z equals to negative 1. We have y equal to 3. And then lastly, we have x is equal to positive 1. Typically, we like to write it with our x on the top one. So we can switch rows 1.3 and 3.3 to get x is equal to 1, y is equal to 3, and then z is equal to positive 1. And that way, we have our variables in descending order. If we wanted to write this as a point, a coordinate triple, we would write it like a coordinate pair, but with 3 numbers. So 1, 3, 1. Either way you want to express your solution, either as a variable list or as a coordinate point, is correct. Just make sure, if you write it as a coordinate point, that you put the numbers in the correct order. If you put like 311 or 113, that would be incorrect, because this implies x is 1, y is 3, and z is 1. So be careful with the order of your answers if you write them as points. If you write it as a list of variables, ideally, you would take that extra step to put them in order. But if you kept it like this, z equals 1, y equals 3, x equals 1, you're still clearly stating which variable has which value. So that would be correct as well. And so with this, this is pretty much everything there is to show you for this first system or first lesson. on solving systems of equation using the elimination method.